All right, let's dive right in. Today, we're basically playing detective. We're investigating this silent, really costly crime that's happening on farms all across the globe. We're opening the case file on the Liver Fluke. So where do we start? Well, like any good investigation, we start at the crime scene.
So the crime itself goes by a pretty grim name, liver rot. I mean, just the sound of it tells you something seriously destructive is going on inside one of the body's most vital organs, right? But what does that actually mean for the victims here?
Well, liver rot is actually the common name for a disease that scientists call fasciolosis, and it's a huge deal. It's a parasitic disease that just devastates livestock. We're talking sheep, cattle, you name it. And the consequences, they're pretty severe. We're looking at less milk, less meat, and just massive economic losses for farmers everywhere. So if we want to stop this, we first have to figure out who or what is behind it.
Okay, so let's profile our suspect. Every good investigation needs to identify the culprit, right? So let's build a profile of the organism that's causing all this chaos.
And here it is, our number one suspect, Fasciola hepatica. You might know it as the common liver fluke. Now, this thing is a parasitic flatworm, part of a group called trematodes. And what you need to know about trematodes is that they're basically a specialized class of parasites famous for their incredibly complex life cycles. And believe me, this small, kind of simple-looking creature, it is the absolute mastermind behind the entire liver rot operation.
So let's take a look at this guy's rap sheet. What makes it tick? Its appearance is actually pretty deceptive. It's just leaf-like and flat. But don't let that fool you. Its weapons are no joke. It's got two powerful suckers, an oral one and a ventral one, that let it just latch on and hold tight. And its target? Oh, it's very specific. It goes after the bile ducts of grazing animals. Think sheep and cattle. And once it's there, it sets up shop and starts its destructive work.
All right, so to really understand how this parasite pulls off its whole operation, we've got to follow its trail. The liver fluke's life cycle is, well, it's incredibly complex. And it's this intricate journey that makes it such a successful and sneaky opponent.
Okay, so here's a key piece of the puzzle. The fluke's master plan has one huge vulnerability. It can't do it alone. It absolutely has to have a two-host strategy. First, you've got the definitive host. That's our sheep or cow, where the adult fluke lives, grows, and reproduces. But, and this is a big but, to even get there, it needs an accomplice, the intermediate host, which is a very specific type of freshwater snail. Seriously, without this snail, the whole operation just completely falls apart. It's a critical link.
So let's walk through the fluke's playbook, step by step. It all starts with step 1, the release. Eggs get passed out onto the pasture in the host's feces. Then, step 2, the search. Once those eggs hit water, a tiny little larva hatches, and it has just hours to find that specific snail accomplice. Then, things get wild. Steps 3 and 4 are the transformation and the escape. Inside that snail, the larva basically clones itself, multiplying into thousands of new larvae, which then bust out of the snail and swim back into the water. Step 5 is the ambush. These little swimmers attach themselves to plants, like blades of grass, and form a tough little cyst. This is the infective stage, just waiting. And finally, step 6, the invasion. An unsuspecting sheep or cow comes along, eats that plant, and boom, the cycle is complete and we have a new victim.
So the invasion was a success. The fluke is now inside its final host, so let's go inside and take a look at the crime scene and really assess the damage it's causing.
Now, you'd think once it's swallowed, it would just travel through the bloodstream or something, right? Nope. These juvenile flukes do not take the easy route. They actually burrow out of the intestine and start this destructive migration, literally tunneling their way through the liver tissue. I mean, just imagine that. This journey alone causes a ton of trauma and inflammation. It's weakening the animal long before the fluke even gets where it's going. And when these infections become chronic, the parasite leaves behind some very distinct long-term evidence. It's a signature calling card, a condition with a really descriptive name, pipe stem liver.
So what in the world is pipe stem liver? Well, it works like this. The adult flukes are just hanging out in the bile ducts, causing constant irritation. The body's immune system, of course, tries to fight back, which leads to chronic inflammation. Over time, this causes scarring and fibrosis, which thickens the walls of the ducts. Now, in cattle especially, these scarred ducts often calcify. They get hard and rigid with calcium deposits. So when you actually look at an infected liver, these hardened ducts stick out, and they look just like the stems of old clay pipes. It's this unmistakable sign of the fluke's long-term handiwork.
And the consequences of all this internal damage, they're really, really severe.
You've got liver function that just plummets because the bile ducts are blocked and scarred. This leads to a total breakdown of the animal's health, which brings us right back to those devastating production losses we talked about at the beginning. And it's wild to think that all of this is caused by one single, persistent parasite.
Okay, so let's recap. We've identified our suspect, we've traced its movements, and we've assessed the damage. Now it's time for the final piece of our investigation, figuring out why this opponent is so incredibly hard to stop.
Look, trying to control the liver fluke is a massive challenge, and here's why. First, you've got that crazy life cycle that spans two totally different worlds, inside the host's body and out in the snail's watery home. Second, its eggs are super hardy. They can survive on a pasture for months, just waiting. Third, its snail accomplice, it's pretty widespread in any wet, marshy grazing area. And finally, the actual moment of transmission is completely silent and invisible. It's just an animal taking a bite of grass. How do you even begin to fight that?
So here's the most important takeaway from all of this. You simply can't fight what you don't understand. It's only by mapping out this parasite's incredibly intricate journey, from the pasture to the snail to the liver, that we can start to spot the weak links in its chain. That knowledge right there is our best weapon. It's the key to finally breaking the cycle and ultimately to protecting animal health and even our global food supply.
When you think about it, the liver fluke's entire survival is this high-stakes drama. It depends on this perfect storm of conditions, the right hosts, the right environment, the right timing. It's an amazing reminder of all the hidden complexity that's constantly going on in the world around us. And it leaves me with one final question for you. How many other complex dramas just like this one are unfolding, completely unseen, in the world we walk through every single day?